Good morning. Today we will continue the problems on vector algebra. So last time we have studied some problems to find out the projection of a vector in the direction of another vector. The same projection of a particular vector in the direction of other vector also can be obtained by another method, by finding the unit vector in the direction of the vector in which we are interested to obtain the component of the other vector. So here we are asked to find out the projection of the vector b bar expressed as I cap plus 5j cap plus 3k cap on the vector a bar expressed as 2I cap plus 3j cap plus 6k cap. So let us consider we have this vector a bar and we have this vector b bar. So angle between the two is say theta. If we draw the projection from the end point of b bar on a bar, then this vector represents the component of b bar in the direction of vector a bar, and this component will be b cos theta, where theta is the angle between the two given vectors a bar and b bar. So we are interested to obtain what is this component of vector b bar in the direction of vector a bar. So let us consider we have the vector n cap is the unit vector in the direction of a bar. Let us consider n cap is the unit vector in the direction of vector a bar. So if n cap is the unit vector in the direction of vector a bar, then we can express the unit vector n cap as the ratio of the given vector a bar to its magnitude. The ratio of the given vector a bar to its magnitude gives us the unit vector in the direction of the given vector a bar. Now here the projection of the vector b bar in the direction of vector a bar is b cos theta. So projection of b bar along a bar will be equal to b cos theta. The component of b bar in the direction of a bar will be equal to b cos theta. We know that the dot product of the two vectors a bar and b bar is expressed as a b cos theta. So from this expression we can express b cos theta to be equal to, what will be b cos theta? B cos theta will be equal to a bar dot b bar divided by a, and a is nothing but the modulus of a bar or magnitude of a bar. But we have this ratio a bar upon mod a bar as n cap. So we can replace this ratio a bar upon mod a bar by n cap. Therefore we can write b cos theta, the component of b bar in the direction of a bar, or the projection of b bar along a bar, is equal to n cap dot b bar. It is equal to n cap dot b bar. Now we can find out the unit vector n cap in the direction of vector a bar. So here we are given vector a bar expressed as 2I cap plus 3j cap plus 6k cap. Therefore n cap is equal to 2i cap plus 3j cap plus 6k cap divided by mod a bar is under root ax square plus ay square plus az square. So ax is 2, its square is 4, ay is 3, its square is 9, plus az is 6, its square is 36. So this is 36 plus 4 is 40 plus 9 is 49, root 49 is 7. So this unit vector n cap then can be expressed as 2 by 7 I cap plus 3 by 7 j cap plus 6 by 7 k cap. So this is the unit vector n cap in the direction of the vector a bar. And using this expression for n cap and the given vector b bar, here we can find out the dot product of n cap and b bar, which will give us the component of b bar in the direction of vector a bar. So this is equal to 2 by 7 I cap plus 3 by 7 j cap plus 6 by 7 k cap dot b bar is I cap plus 5 j cap plus 3 k cap. So this is equal to 2 by 7 plus 3 by 7 into 5 is 15 by 7 plus 6 by 7 into 3 is 18 by 7. So LCM is 7. So this is equal to 7. 33 plus 2 is 35. So 35 by 7. So B cos theta works out to be equal to 5. B cos theta works out to be equal to 5. So the component of the vector b bar in the direction of vector a bar works out to be equal to 5 units. That you can say 5 units. So that is how we can find out the component of a given vector in the direction of other vector by obtaining the unit vector in the direction of vector a bar, in which we are interested to find out the component of the other vector. So that is this problem, to find out the component of a vector in the direction of other vector. So next we will see another problem. Next is, you are asked to show that modulus of a bar cos b bar square plus modulus of a bar dot b bar square is equal to mod a square into mod b square. So here you are asked to show that square of the modulus of a bar cross b bar plus square of modulus of a bar dot b bar is equal to mod a square into mod b square. So to prove this relation, we can use the definitions of dot product and cross product of two vectors. We have seen that the cross product of two vectors a bar and b bar is expressed as a b sin theta. The cross product of a bar and b bar is expressed as a b sin theta. where A and B are the magnitudes of the two given vectors A bar and B bar, and theta is the angle between the two given vectors. Similarly, the dot product of two vectors A bar and B bar is expressed as A B cos theta. The dot product of A bar and B bar is expressed as A B cos theta. This is a vector. A bar cross B bar is a vector, so it can be expressed as AB sin theta into n cap, rather you can say, because it is a vector quantity. And the dot product of A bar and B bar is a scalar quantity, so it can simply be expressed as AB cos theta. So if A bar cross B bar is a vector, then its magnitude is given by A bar modulus of A bar cross B bar is equal to AB sin theta. It is equal to AB sin theta. And A bar dot B bar itself is a scalar quantity, but still then we can write modulus of A bar dot B bar is equal to AB cos theta. So, using these expressions for modulus of A bar cross B bar and modulus of A bar dot B bar, here we get, therefore, modulus of A bar cross B bar square plus modulus of A bar dot B bar square is equal to, we replace the value of modulus of A bar cross B bar by AB sin theta and modulus of A bar dot B bar by AB cos theta. So we get A square B square sin square theta plus A square B square cos square theta. So this is equal to A square into B square into bracket, it is sin square theta plus cos square theta, and sin square theta plus cos square theta is 1, so this is equal to A square into B square, or this is nothing but equal to mod A bar square into mod B bar square. So that is what we are asked to prove here. So modulus of A bar cross B bar square plus modulus of A bar dot B bar square works out to be equal to mod A bar square into mod B bar square. So that is how we can prove this identity. Next, we shall study another problem to determine the unit vector perpendicular to the plane of the two given vectors. Next problem, determine a unit vector perpendicular to the plane of A bar equal to 2i cap minus 6j cap minus 3k cap and B bar equal to 4i cap plus 3j cap minus k cap. So we are given the two vectors A bar and B bar here, and you are asked to find out the unit vector perpendicular to the plane of A bar and B bar. A bar and B bar. We want to find out the unit vector in the direction perpendicular to the plane of A bar and B bar. So let us consider we have this vector E bar and this is the vector B bar. Suppose this is the plane of A bar and B bar. Theta is the angle between the two given vectors. So if we draw a vector C bar perpendicular to the plane of A bar and B bar. Suppose this is the vector C bar which is perpendicular to the plane of A bar and B bar. So we are asked to find out the unit vector in the direction of this vector C bar. Suppose n cap is the unit vector in the direction perpendicular to the plane of A bar and B bar. So while obtaining the unit vector in the direction perpendicular to the plane containing the two given vectors A bar and B bar, let us first obtain the vector C bar perpendicular to the plane of A bar and B bar. So this vector C bar, let us consider C bar is perpendicular to the plane of A bar and B bar. So this vector C bar, let C bar is perpendicular to plane of A bar and B bar. So this vector C bar can be expressed as C bar is equal to C1 I cap plus C2 j cap plus C3 k cap, where C1, C2 and C3 are the x, y and z components of the vector C bar. Now, since this vector C bar is perpendicular to the plane of A bar and B bar, it means that this vector C bar is perpendicular to the vector A bar as well as it is perpendicular to the vector B bar. And as we know well that if we have the two given vectors which are mutually perpendicular to each other, then their dot product works out to be equal to 0. So if the two given vectors are mutually perpendicular to each other, their dot product works out to be equal to 0. So evaluating the dot product of this vector C bar with A bar and the dot product of C bar with B bar and equating this dot product to 0, we shall get the expressions in terms of C1, C2 and C3, and by solving these two equations simultaneously, we can find out the values of C1, C1 and C2 in terms of C3, and we can find out the unit vector in the direction of the vector C bar. So let us first find out the dot product C bar dot E bar. The vector C bar is expressed as C1 I cap plus C2 j cap plus C3 k cap, and the vector A bar is expressed as 2 I cap minus 6 j cap minus 3 k cap. So the dot product of C bar with A bar will be twice C1 minus 6 C2 minus 3 C3, and this must be equal to 0 because the vectors C bar and E bar are perpendicular to each other. So if we consider this equality, we can write this expression as twice C1 minus 6 C2 minus 3 C3 is equal to 0, and transferring this term to the right hand side, we can express this as twice C1 minus 6 C2 is equal to 3 C3. Say this is equation number 1. Then evaluating the dot product of C bar with B bar, we get C bar dot B bar is equal to C bar dot B bar is equal to 4C1 plus 3C2 minus C3, and this must be equal to 0 because the vectors C bar and B bar are mutually perpendicular to each other. So this expression implies that 4C1 plus 3C2 minus C3 is equal to 0, and transferring this term to the right hand side, we can express it as 4C1 plus 3C2 is equal to C3. Say this is equation number 2. Now by solving these equations 1 and 2 simultaneously, we can obtain the expressions for C1 and C2 in terms of C3. So we get, by solving these two expressions, we get in order to obtain the value of C1 in terms of C3, what we have to do is from equations 1 and 2. We have these two equations. So multiply, we have to eliminate C2 from these two expressions. So to eliminate C2, what we have to do is we have to multiply equation 1 by 3 and equation 2 by 6 and take the addition. So equation 1 multiplied by 3 plus equation 2 multiplied by 6. So this will give us 1 multiplied by 3 is 6C1 minus 18C2 is equal to 9C3, and multiplying equation 2 by 6 we get 24C1 plus 18C2 is equal to 6C3, and taking the addition of these two expressions, this plus 18C2 and minus 18C2 will cancel. So this is 6C1 plus 24C1 is 30C1 is equal to 9 plus 6 is 15C3. So this implies that C1 is equal to 1/2 C3. C1 is equal to 1/2 C3. So here we have obtained the value of C1 in terms of C3. Similarly, we can find out the value of C2 in terms of C3. The value of C2 in terms of, in order to obtain the value of C2 in terms of C3, what we need to do is we have to eliminate C1 from these two expressions. And to eliminate C1 from equation 1 and 2, what we need to do is we have to multiply equation 1 by 4 minus equation 2 multiplied by 2 and take the subtraction. Multiply equation 1 by 4 and multiply equation 2 by 2 and take the subtraction. So multiplying equation 1 by 4 we get 8C1 minus 24C2 is equal to 12C3, and equation 2 multiplied by 2 is 8C1 plus 6C2 is equal to 2C3, and we have to take the subtraction of the 2, so the signs of these expressions will get reversed. So okay, so this is minus and this is minus. So plus 8C1 minus 8C1 will get cancelled. This is minus 24C2 minus 6C2 is minus 30C2 is equal to 12 minus 2 is 10 C3. And this implies C2 is equal to C2 is equal to minus 1 by 3 C3. So we have obtained the values of C1 and C2 in terms of C3. And using these expressions for C1 and C2 in the expression for C bar, we get, therefore, C bar is equal to kind. Therefore, C bar is equal to C1 I cap. C1 is 1/2 C3 I cap minus plus C2 J cap, and C2 is equal to minus 1 by 3 C3. So it is minus 1 by 3 C3 J cap plus C3 K cap. So C1 and C2 are replaced in terms of C3. So we can take C3 common. So this is equal to C3 into bracket 1/2 I cap minus 1 by 3 J cap plus K cap. So this is the vector C bar. And now we can find out the unit vector in the direction of this vector C bar. As we know that as per the definition of the unit vector in the direction of a given vector, we have seen that the unit vector in the direction of the given vector is expressed as the ratio of the given vector C bar to its magnitude. The unit vector in the direction of the given vector is expressed as the ratio of the given vector C bar to its magnitude. So this is nothing but equal to C bar is C3 into bracket 1/2 I cap minus 1 by 3 J cap plus K cap divided by its magnitude. Magnitude is under root ax square plus ay square plus az square. What is the value of ax here? Ax is C3 by 2. Ay is minus C3 by 3. And az is C3. So its a square will be C3 square upon 4 plus C3 square upon 9 plus C3 square. So this is the magnitude of the vector C bar. So this is nothing but equal to. If we take C3 square common from the three terms in the denominator, it will come out of the square root sign as C3, and this C3 and that C3 will get cancelled. So this is nothing but 1/2 I cap minus 1/3 J cap plus K cap divided by, it is under root of 1 by 4 plus 1 by 9 plus 1. So this works out to be equal to 1 by 4 plus 1 by 9. So LCM will be 36. So it is 9 plus 4 plus 36. So this is 36 plus 4 is 40 plus 9 is 49. Square root 49 is 7 and square root 36 is 6. So this will be 6 by 7. So this is 6 by 7 into bracket. It is 1/2 I cap minus 1 by 3 J cap plus K cap. So this will be plus minus because it is the square root. So square root of 49 by 36 will be plus minus 6 by 7 in the numerator. So this is this. So if we multiply in the bracket by 6 by 7, this expression can be expressed as, so this is equal to, therefore n cap is equal to plus minus into bracket 6 by 7 into 1 by 2 is 3 by 7 I cap minus 6 by 3 is 2 by 7 j cap plus 6 by 7 k cap. So this is the required unit vector in the direction perpendicular to the plane of A bar and B bar. So this vector gives the unit vector perpendicular to the plane of A bar and B bar. So that is how we can find out the unit vector perpendicular to the plane of the given two vectors A bar and B bar. So with that we close it here for today then, and in the next video we'll continue. Thank you.